The AI models answering your questions, the chips inside your phone, and the GPUs training the world's most advanced AI models all trace back to a single machine. And it's not sitting in Silicon Valley or in Taiwan, it's in a Dutch city of just 45,000 people. We are talking about a machine so strategically important that a single phone call from Washington stopped it from ever reaching to China. When the news of that decision broke, most people thought it's about politics or a trade dispute. But they were looking at the wrong thing entirely. That call wasn't just about politics, and it wasn't just about machine itself. So why would this phone call from Washington to Netherlands turn out to be the most consequential decisions in semiconductor history? And if they weren't just protecting the machine, what were they really protecting? I'm a semiconductor engineer working on a next generation of AI chips. I've stood inside the clean rooms where these unique machines print silicon. It's called EUV lithography scanner, weighing roughly 180 tons. It has to be broken down into specialized modules just to fit into cargo aircraft. In fact, the optical column alone requires its own dedicated flight. It costs up to $400 million. ASML is the only entity on Earth building these machines at production scale. But that massive scale hides a terrifying vulnerability. 11 weeks. That's long how it takes to recalibrate the optics after a vibration literally smaller than a human heartbeat shifted the machine out of tolerance. The margin of error is almost zero. To print pathways barely wider than a few atoms, ASML fires a laser at a droplets of molten tin 50,000 times a second, creating a plasma that briefly matches the temperature of the sun. If that extreme physics drifts even slightly, $30,000 of pure silicon doesn't get reworked, it gets scrapped. Looking at that insane level of precision, the conclusion seems obvious. ASML must control the whole chip supply. But here's a question that changes the view. If ASML controls the chip supply, then is there anyone who actually controls ASML? The extreme precision mirrors focusing that light come from Carl Zeiss in Germany. To give you an idea how perfect they are, if Carl Zeiss decides to make these mirrors at the size of whole Earth, then the biggest bump on that would be even smaller than a width of human hair. ASML owns the quarter of the division as a structural insurance. The laser source comes from Cymer, a California-based company ASML acquired for $2.5 billion. The chemical photoresist comes from specialized suppliers in Japan, like JSR, Shinitsu. Yet the modern semiconductor industry cannot function without all of them. Remove any single node and the machine cannot be built. This isn't just a supply chain, it's a structural lock. This is a co-evolved industrial ecosystem that grew and failed together for decades. Every single wafer run teaches the system something new. Millions of manufacturing decisions have been encoded into this network over decades, and most of them were learned through the failure. That knowledge instantly flows back through the network, influencing how ASML calibrates, how Zeiss refines, and how Japan formulates. Which brings us back to Washington. When people talk about technology sanctions, they assume the goal is blocking the hardware. It isn't. The hardware is just a visible part. Export controls were actually designed to break the feedback loop. China was cut off from that learning loop in 2019. The challenge they face today isn't reproducing one machine. It's reproducing 40 years of accumulated lessons while the original system keeps learning. Often China tries to make lab prototypes of these machines. But a lab prototype is not a manufacturing tool, and you simply cannot fund your way to decades of institutional memory. That quiet licensing decision in Netherlands may turn out to be one of the most consequential decisions in the modern industrial history, because it serves as case study in how technological civilizations actually accumulate knowledge. This entire global system was never deliberately designed. It simply emerged from engineers across multiple countries solving impossible problems together. The semiconductor industry has spent decades optimizing hardware, but far less attention has been paid to what happens when the knowledge network itself breaks. Hardware can be rebuilt, factories can be financed, engineers can be hired, but the institutional memory only compounds with time, and time is the only one thing which no country can manufacture. Subscribe if this kind of analysis, where engineering, finance, and real industry context all meet, is what you're looking for. This is exactly what I cover here. Thank you.